So for C, Tangataka calculate the appropriate test statistic and show your answer and it. So I Tangataka it two my samples and it, but anyway which is less than 10 and that is actually population standard deviation and it. So we use the T statistic. It one per page 2 of a formula booklet. It and it. You notice on his own. We are saying T is equals to tunoshandisa formula yedu iyi handiti iri formula booklet yedu pa page 2 under interferences containing two samples handiti or T statistic handiti mu1 ne mu2 takapiwa panapa handiti sp our pooled standard deviation tamuwana pa b handiti and the sample size for n1 and n2 tinayo handiti and for this handiti hanzi mu1 minus mu2 but let's take a look at now hypothesis peda handiti hanzi mu A is equals to mu B and it. So if we subtract mu B from the right hand side and it becomes mu A minus mu B is equals to 0 and it. So this equate this part to 0 and it. So let's replace my values here to find the T statistic and it. X1 is 120 minus 128.3 and it this start equals to 0, so minus 0 over SP wedu chamwana pa BRG at 6.88 and this multiplying the square root of 1 over 10 plus 1 over 1 over 10 and this. So if you punch that into our calculators, so if we punch our T statistics, angachi BRG negative 2.699 and this. Let's move on to per D and this. So per C chat negative 2.699 and it. And for D, so that's the for D, determine the degree of freedom for this test and it. And for DF, degree of freedom and it. Can I tell you two samples and it? Note N1 plus N2 minus 2 and it. So N1 plus N2, that was 10 plus 10 and it minus 2 and it. 10 plus 10 20 minus 2 of a degree of freedom of 18 and this. Then to move on to per EN using a significance level of 0.05, find the critical value for this hypothesis test and it. How far we do the sorry, 0.05 and it. So we are saying to per T table pane significance level of pane degree of freedom of 18 watawana and it. How far is R is 0.05 and it. So we use T table and I'll place the link of this more video description and it. So we are saying good it pana 18 and it pana and it. This was the one to test 0.05 so zika pana and it kushka pana 18 and it's right here. It's 1.734 and it. So answer do for E was 1.734 and Tashika pa F and based on the calculated test statistic in the critical value, what conclusion can you draw about the performance of the two sorting algorithm? So for alternate hypothesis and it, we're saying algorithm A is less than B and it. So if we draw our graph and use it, we assume normal distribution and it's a bell shape and it. So if alpha that which we are investigating is less than to left inside and it. In critical value and do you touching the calculator pan negative. So this was negative 1.734 and it. So this is the rejection region. So if our calculated statistics value falls below this and it, we reject it, and this one acceptance region and it. We want this region we reject H0 to the null hypothesis and it. And in this region going right and it, we accept our null hypothesis, right? madesauya. Alright, so taona value chi calculated pasi angari negative 2.69. That means kuti angari kunoku negative 2.669, negative 2.699 and it. So this value is falling in the rejection region and it. So we reject H naught and it angachitichi performance algorithm A is equating to algorithm B and it. So we are saying which there is statistically significant evidence that at 5% level to conclude that algorithm A has lower average execution time than algorithm B.